Hello everyone, thanks for tuning in. We are now in fourth lecture, and in this lecture we will be talking about we will be discussing some problems related to kinematics. I have six problems here. We will do each problem one by one and um, try to solve each problem thoroughly. So let's see the first problem. Here it goes. We have a situation here. We have two policemen, just like in the previous example that we have done. The velocity here is 2 meter per second. The initial velocity vi for the first question is 2 meter per second, and then the final velocity is 15 meter per second. We have to find the distance d if the acceleration is given 2 meter per second square. Just before solving this question, I just wanted to clearly highlight some of the three main important equations for the kinematics. Vf is equal to vi plus at. This is the first equation. Then 2as or d, it's up to you. Vf square minus vi square, and s is equal to vit plus half at square. Since we are in the problem solving module, we assume that we know these equations. At least we know how to drive these equations. If there is an issue with the derivation of these equations, I will do it later. But let's assume that we know these equations. Just assume that we know these equations. Okay, so let's see that which quantities we have and which equation is best to use. Okay, before solving any kinematic problem, we have to see that which variables are present, and then we have to choose which equation is better. Okay, all right. One important thing to solve an equation, you should have only one variable. Okay, there has to be only one variable, otherwise you can't solve an equation. Okay, so the thing is, our variable is d. We don't know the d. Okay, we can't find d here, so we can't use this equation. We have d here and d here. The distance s or d is up to you. Let's call it s. Okay, so we have s here, s here. All right, so we can use this equation and this equation. But let's see how many variables, how many known quantities we have. We have vf, okay, known. Vi, okay, known. We have acceleration, I is known. So we have only s unknown. This equation looks promising, but let's go with this equation and see if this can be used. Okay, so we have s unknown, vi known, t is unknown. That means we cannot use this equation. So only possible way to go with the solution is to use this equation. Okay, so 2as is equal to vf square minus vi square, right? So 2a is 2 meter per second, s is unknown, is equal to vf, which is 15 square, minus vi, which is 2 square. Okay, one more thing, just to make sure that you are doing correctly, make sure that the units are consistent. Otherwise you have to convert the units before going on to solve the equation. So in this case, since your units are consistent, we can solve the problem. So s is equal to 15 square minus 2 square divided by 4, which gives 15 square minus 2 square divided by 4. So the distance is 55.25 meters. Now let me tell you how you have the meters. Okay, this unit, right? So okay, VF square means meter square per second square, right? would have the same units, because without the same units you cannot subtract two quantities. They should have the same units to have subtract, so to have addition or subtraction. So the this whole quantity has a unit of meter square per second square, divided by 2 has no units. The only thing that is A, right? So A has meter per second square units. So the only thing that remains now, this is meter square per second square. Now you will do the reciprocal thing. So you have second square up there and meter come down there. So the thing that remains is meter. So that's why the unit of S is in meters. Okay, you can also use units each time, but the best thing is to use the units at the end, because it's much easier. Otherwise you can use units everywhere and then solve the equation, uh, but this way you should know that why we have meters here. Okay, question number 2. Now question number 2 is more into the the evaluation of the equations that we have. Vf is equal to vi plus at, 2as is equal to vf square minus vi square, and s is equal to vit plus half at square. So what we have to do is we have to make sure that these equations are dimensionally correct, dimensionally consistent or correct. What do we mean by that? Dimensionally correct means that you can only add two quantities of same units. I mean, you can add 2 apples with 4 apples to give 6 apples, but you cannot add 2 apples with 4 bananas to have 6 something, which does not make any sense. So that means that in any equation the terms must have the same units. This term, this term, this term, all three must have same units. So Vf has a unit of meter per second because it's velocity. Vi is also have meter per second, and At, the units of A is meter per second square, and the unit of time is second. So you have meter per second, meter per second, meter per second. So that means this equation is dimensionally correct. Now here the unit of a 2 is a constant. It does not have any units, so you can ignore 2. The only thing that you have is acceleration. The unit of acceleration is meter per second square. Okay, and then s, the distance, which is unit of meters. Okay, vf, since it's velocity, so meter per second square is whole square. Vi, meter per second whole square. So combining all these, so all three quantities have same units, so it means the equation is dimensionally correct. Now let's come to this, the third one. S is equal to vit plus half at square. So the unit of s is meters, the new unit of vi is meter per second, and you have time, so the unit of time is second. Now half, again 1 or 2 is constant, so it does not have any units, so you can ignore it. The units of acceleration is meter per second square. Then you multiply it with second square, because t square means second square, so second cancels, second square cancels, so only thing that remains is meter, meter, meter. So all three are dimensionally correct. So that's how you evaluate the consistency um, of the three main pillars of kinematics. So these three equations are the pillars of the kinematics. Just to tell you more about these equations. These equations are valid only when acceleration is constant. Okay, acceleration is constant. And one more thing, that all these things, all the questions that we are doing by taking supposition that we are moving in 1D and in a particular direction. Okay, that means that we are simplifying our problems by considering that we are only moving in one direction and we are not changing the direction. Otherwise things get complicated. We will not go into the details. However, we will see some problems where we will go in the backward direction. uh, but for now, because these problems are just introductory problems, we are only going in one direction. Okay, so everything um, it's very simplified, very easy, that's why. But we will introduce the problems where we move in backward direction and how things get compli- complicated. And yeah, it's better to have steps down the way to have a better grasp on the concepts. The third question is easier. I think it's very easy question. Again, you can see the third question says that you have a car. Okay, this is question number 2. This is question number 3. Question number 3 is about the same scenario. You have a car and there is a policeman measuring the velocity of the car. Okay, vi is 2 meter per second, and then you have the distance that the distance is given, which is 4 meters, and the time taken for the car to move from this point to this point is 6 seconds. We have to find vf. Okay, all right, let's see which equation is correct, or might be possible we might have some missing information. But let's see how the thing goes, you know. Okay, we have to find vf. All right, again listing the three main equations. Vf is equal to vi plus at, then 2as is equal to vf square minus vi square, and then s is equal to vit plus half at square. All right, we have vi, we have t, but we don't have acceleration. So we have vf, which is the unknown quantity that we have to find. We have vi, we have t, but we don't have a, so we can't use this equation because it has two variables. This equation, we have a unknown, s unknown, s known, s is known. We have vf, we don't have vf, we have vi. So there are two variables, a and vf, so this cannot be used. All right, s is known, vi is known, t is known. Okay, half a is unknown, t is known. That means, see, sometimes equations help each other. What we can suggest is we can find acceleration from this equation, and we can substitute the acceleration here to get the final velocity. That's the trick, I think. So s is 4 meters, vi is 2 meter per second, time is 6 seconds plus half, a is unknown, okay, and time is 6 seconds square. So 4 is equal to 12 plus a divided by 2, 6 square. Okay, let's see. 4 minus 12 minus 8 multiplied by 2. Okay, divided by 6 square. This gives an acceleration of minus 0.444 meter per second square. Okay, it's just we have to find the a, right? So okay, let's I've not written some steps. Let's write them clearly. It's 4 minus 12, okay, this goes there, multiply by 2 divided by 6 square is a. Okay, so from here you get a minus 0.444 meter per second square. Now this minus is strange because so far we haven't seen any minus, right, in the quantities, but the minus has its own significance. This minus gives the direction, right? So in other words, if we have minus, the first concept that we can get is we have decrease in velocity, okay, and the second concept we have is about the direction that we will not introduce now, but in this case, since it's minus, we just assume that it's decrease in velocity. Okay, the velocity will what does that mean is the initial velocity will be higher than the final velocity. Okay, so let's see. So after getting the acceleration, which is minus 0.444, we have vf is equal to 2 minus 0.444 into t, which is 6. 2 minus 0.444. Okay, so our vf is minus 0.664 meter per second. Right, things are getting complicated now. Again, we have a minus sign here. All right, so what does this minus sign tells you? The minus sign says that the velocity at this point is not in the forward direction, it's in the backward direction. The policeman, whoever whoever he is, has measured the velocity to be 0.664, but not in this direction, but in the backward direction. Okay, all right, we will have further further detailed analysis on minus signs, because of course these are difficult concepts to grasp. We will have detailed analysis on this, but for now, for time being, if you have velocity of minus sign, that means the direction of the movement is actually in the opposite direction, and if the acceleration is negative, that means the object is actually